All right, everybody, go ahead and title your notes. Multiplying and dividing rationals or rational expressions. Please go ahead and begin with the following warm-up. Go ahead and do the following, please. Here's your first example. I want you to solve 3 over 4 times 5 over 7. And then I want you to solve 3 over 4 times 16 over 9. Okay, take about 2 minutes. All right, everybody, let's take a look. Okay, 3 over 4 times 5 over 7 is equal to what? What can I reduce this to? Let me hear from Kayla. What do I get when I multiply this? 15 over 28. Can I reduce 15 over 28? No, there is no common factor between 15 and 28 aside from 1. What do I get when I multiply the second equation across, without simplifying yet, of course? So 16 times 3 gives me what? 48. What's the bottom? 36. What is the greatest common factor between 48 and 36? 6 is a factor, but not the biggest common factor. Tolson. 12. So we can divide top and bottom by 12. And once we divide top and bottom by 12, then we can get our final solution of 4 over 3, 4/3. Okay? All right. So we're going to be looking today at not just simplifying expressions, rational expressions, but multiplying and also dividing rational expressions as well. Now, the steps for multiplying and dividing rational expressions are quite simple because, as you saw, when it comes to fractions, we can just multiply across. All right. So let's jump into some notes. Okay. So let's talk about multiplication first. Okay, when it comes to multiplication, your first step will be to find the GCF if applicable. And or you might have to factor. Okay. So it is likely that you will have to reduce your initial expression by something. You might have to reduce it using the GCF, or you might have to reduce it by simplifying with a factoring. Just like before, your second step will be to find the excluded values. You always want to find your excluded values before you start canceling stuff out. Otherwise, you will not get the full picture. You might just get one excluded value or two excluded values, and there might be more than whatever is in the very end. All right. Once you find your excluded values, then your step 3, you can simplify. And typically what this means is you can start canceling out terms. Okay. So once again, you will want to reduce your initial expression, but not fully. You'll just want to reduce some of it. Then you'll find the excluded values, and then after you have found the excluded values is when you can go ahead and start canceling things out, and then get your final answer. Okay. So let's start with the following example. Let's say I want to multiply the following two expressions: 25x minus 10 over 25x to the third minus 10x to the second. And we want to multiply this with x plus 2 over 5. Okay. So go ahead and copy this problem down. Now, as you know, we always start out with an easy one, so don't stress too much about this one. The next one, that's the one that has a lot of steps. But anyway, so let's begin by looking at, well, let's look at it as a whole. If I look at the second equation, is there anything I can reduce from the second equation or the second expression? Like x plus 2 over 5, I can't take out any x's, I can't take out any 5's, there's like nothing I can do. So obviously all the work we're going to do is actually going to be with the first part of the expression. It's going to be with this first fraction. 25x minus 10. Look at the numbers. 25 and 10. 25 and 10 share a common factor of what? Of 5. So I'm looking ahead. I can tell that, yeah, from the top, I'm going to take out a 5. Then let's look at the bottom. 25x to the third and 10x squared. So same numbers, 25 and 10. So I know my GCF is 5. But you will notice that they also share some variables. How many variables? They share 2 variables. So this is what's going to happen. From the top, our GCF will be 5. Underneath, our GCF will be 5x squared. Okay. I know it's hard to see, but just do your best to try to write this down. Once again, from the top, our GCF is just the number 5. From the bottom, our GCF is 5 and also a pair of variables, x squared. So let's go ahead and write the next line. If I'm taking out a 5 from the top, then I'm going to have a 5 on the outside. And inside my parentheses, I'm going to have the terms to get me back to what I started with. So 5 times 5x will get me back to 25x. And 5 times negative 2 will get me back to negative 10. That is the numerator of my first fraction. That is how it is going to look like once it is simplified. From the denominator, we're taking out a 5x squared. So I'll go ahead and write out a 5x squared. What am I going to have inside my parentheses? 5x minus what? 5x minus 2. And don't forget, we are multiplying all of this by x plus 2 over 5. Okay. Okay. It is at this point that we have to find the excluded values. Why? Because we've already taken our first step of reducing this, like simplifying it, by factoring. We have to find the excluded values now because, as you can see, we are going to cancel some stuff out. And if we skip this step of finding the excluded values now, you won't get all of them. So we're going to find the excluded values for any variables in the denominator. I'm going to find it for 5x squared and 5x minus 2. I'm not going to find it for 5 because 5 doesn't have a variable. So you forget about that 5 right there. To find the EVs, you're going to take each of these factors and set them equal to 0. So we have 5x squared equals 0, and we have 5x minus 2 equals 0. Let's go ahead and solve for x. And let me just kind of do a little break so you guys don't mix that up. 5x squared equals 0. What will x have to equal for the first equation so that we get 0? Anything times this number is going to give you 0. So x has to be 0. And then this second one, we are going to have to solve algebraically. So let's begin by adding the 2. We get 5x equals 2. So x equals 2/5. Okay, so we have a pair of EVs right here. So go ahead and write out your squared values. Take about 20 seconds. And then we'll move back and cancel out, whatever we can cancel out from over here. You guys good with this? All right, so we go back to this now. What can I cancel out? So what do you guys notice is the same in the numerator and denominator that I can get rid of? The most obvious one is 5x minus 2. What else can I get rid of? I can get rid of this 5, and I could either get rid of the 5 here, or I could get rid of this 5 over here. All right, keep in mind we are able to cancel these terms out because we are multiplying. However, am I able to cancel out this x with this x? Why not? Okay, not because it's not squared. That's the same reason. It's a good guess, though. It's a good guess, but it's not quite the reason that we're looking for. What's up? Because we are adding with the 2. So you have to think of this x right here as a group. You can't touch what's inside of this group with what is like out here. All right. So this is a group of x plus 2. You can't just take out the terms and then say, okay, I'm going to cancel with the bottom. All right. You have to remember anything that is being added has to be considered as a group, as a factor. Okay, so we get a final answer of x plus 2 in the numerator and 5x squared in the denominator with our EVs on the right-hand side. Okay. All right. How do you guys like that that problem? Wasn't too bad, right? Good little warm-up, little 7th grade problem. Let's talk pre-calc now, guys. Come on. All right. You guys ready for a good one? We'll do one more, and then we'll actually move on to division. It's kind of the same thing anyway. So. Multiplying and dividing rationals. Do you need me to put it up? Oh. Yeah, you're welcome. All right, let's look at another problem, guys. Second example, here we go. 10x to the 4th minus 5x to the 3rd. Okay, we're all writing this down, yeah? Over. If we're talking, we're not writing. Can't multitask. Come on. 4x squared plus 4x minus 3. And all of this will be multiplied with, let me bring this over here. 4x squared minus 4x minus 15. And 2x squared plus 5x minus 25. All right, go ahead and copy that down, please. All right, you guys ready? I'm gonna need your like full attention for this because there's a lot of stuff that's gonna happen right now. Okay, let's start with the first fraction numerator. I'm gonna highlight that just so I know what I'm working with. Once again, we're gonna start with 10x to the fourth minus 5x to the third. Let me find some space here on the side to work with that. All right, so let's just work with the numerator right now. So that's 10x to the fourth minus 5x to the third. Okay, what can I do with 10x to the fourth minus 5x to the third? I can do GCF, and what will the GCF be? Let's think about let's think about it before we say the answer. Okay, 5 is correct. Yes, you're right. 5 is right, but 5 is not the only thing that we can take out. What else can we take out? We can also take out the x to the third. So the GCF will be 5x to the third. So that means that we're going to get the following. 5x to the third on the outside and 2x minus 1 on the inside. Yep. I'm going to highlight this with the same color just so you guys can be, consistent about what we're doing. And let me split this up. All right, we're going to leave that how it is. We're going to move on. Ready? So now we're going to look at the denominator for the first fraction. So now we're going to look at, I'm going to highlight this in blue. We're going to look at this trinomial in blue. Question? Okay. So now we're going to write that down over here. 4x squared plus 4x. 4x squared plus 4x minus 3. Okay, there it is. All I'm doing is just rewriting it separately, you guys. I'm not doing anything yet. I'm just rewriting it over somewhere else. Okay. How can I reduce this trinomial 4x squared minus 4x minus 3 or plus 4x minus 3? Can I do GCF here? No, because there is no common factor between 3 and 4 unless it's 1. But that doesn't work. And because it's a trinomial, then what method am I looking at? Xbox method. Okay. You try it, and then you can check with what I get. Try it on your own first. Do it on your own. You're checking after you do it. Do it on your own first, and then you can check with my work. You check your work once you've done it. Don't just copy me. Don't just copy me. Try it on your own first. We should be pros at Xbox method. I can take my picture any day this week. Yeah. I don't know. I don't know. Maybe. Maybe I'll go. Because of the dress shirt? Or I might wear a different shirt for the picture. I don't look that old. I want to look uncommon in my picture. Okay. Are we good so far? Thank you. Thank you. Okay, let's move on to the next fraction. Start with the numerator. So now we're going to do 4x squared minus 4x minus 15 over here on the side. Let me... What was it? 4x squared minus 4x minus 15. Okay, go ahead and do Xbox method on this again, please. This time I'm not going to work it out because you guys just copy me. Don't copy me. Do it on your own. Cool. Try it. Try it. You can check your work after you have solved it. If you did it right, you should get the same binomials I got. Not too bad. Not too bad. For everybody. It's pretty good. It's pretty good. It's pretty good. Okay, if you want to start working on the last one, you can. 2x plus 5x minus 25. 2x squared plus 5x minus 25. Let's do that right here. It's the Xbox method. Yeah, you're right. Yeah. 2x squared. What the hell? All right, hold on. 2x squared plus 5x minus 25. Okay. I think we did this in purple. This will be Xbox method again. And once you work this out, you should get the following. And x plus 5. Okay, cool. Yes. X minus what? Oh, it says Xbox. Sorry. Okay, so how are we doing? We all right? Okay, cool. So we're pros with Xbox method, yeah. Cool. All right, let's put this all together then. Oh my god. Skip. Some technical difficulties. Hold on. Okay, I'm just gonna go for it. All right. So from the numerator, we got 5x to the third, 2x minus 1 over 2x plus 3, 2x minus 1. It's not a y, it's an x. Just give it some time. Yeah, it's taking its time. Yeah. I can't afford to make any mistakes here, guys. Otherwise, I can't erase this. Okay. From the numerator on the right-hand side, we got 2x plus 3 and 2x minus 5. And 2x minus 5 over x, or x plus 5. Okay, you know what? You guys you're probably right. I should just put the notes up instead. Yeah. No. Find the excluded values. It's the same thing we had. Find the excluded values. It's the same thing we had. It's just because it's taking a while to write. So. All right. Are there any questions on this first problem? Okay. I'm gonna have to disconnect the computer and then reconnect it. So I'm gonna end the stream right now. All right. Let's look at division. Okay. So with division, don't forget you have to do keep change flip. Keep change flip. KCF. Okay, so we're doing keep, change, flip, then that means we're doing the following. Let's get an example. 4/3 divided by 16 over 9. Okay, so 4/3 divided by 16 over 9, we obviously have two fractions. If we are doing keep, change, flip, then that means we are going to keep the first fraction how it is. We will change the multiplication sign to, we will change the division sign to a multiplication sign, and we'll flip the second fraction. So we'll get the following. 4/3 times, let me not use the x, let me use the dot instead. 4/3 times 9 over 16. Before we multiply straight across, we are going to have to simplify the fractions. So let's look at numerator and denominator. I see a 4 here and I see a 16 here. What is the common factor between 4 and 16? 4 and 16. 4. 4 goes into 4 once. 4 goes into 16 4 times. What about the 9 and the 3? 3. So 3 goes into 3 once. 3 goes into 9 3 times. And I get a final solution of 3 over 4. Okay. All right. Any questions on this question here? Yes, sir. No, not for this one. There are no x's. This is a 4th grade problem right here. Just a review of keep, change, flip. It's a great question though. All right. Ready for some pre-calc work? All right. This is gonna be fun. I don't know why there's so many Xbox methods. Damn. Okay, next example. This is the last example, and then I'm gonna give you guys time for homework. Okay, write this down. We have. Let me get this close to me because there's so many numbers to write down. 5x squared plus x minus 4 over 6x squared minus 7x minus 3 divided by 5x squared minus 9x plus 4 over 6x squared minus 7x minus 3. Cool. What do we do this? Let me give you 5 minutes to Xbox method all this stuff. Nope. First begin by doing the GCF or the Xbox factoring. So just do that for now. Just do the Xbox method or GCF for now on the side, and then we'll come back in about 5 minutes and rewrite all that, and then we'll keep changing. All right, go ahead and get started, please. Okay, everybody look up here, please. So, once again, this is what we should have gotten from the Xbox method factoring. You cannot cancel stuff out yet. This is still a division problem, and we have to do what? Keep, change, flip. So we are going to keep the first fraction how it is. We're going to flip the second one. So we get 5x minus 4 times x plus 1 over 2x minus 3, 3x plus 1. This becomes times now. 2x minus 3, 3x plus 1 over 5x minus 4, x minus 1. So now we have this problem. And you can't cancel out yet. Now you have to find the excluded values for all of these. Yep, all 4 of them. Find the EVs. Once again, you're finding the EVs for all 4 of these. Go ahead and do that right now, please. Once you find these scalar values, you can cancel it out. Okay, check your final answer. Final answer should be x plus 1 over x minus 1. Okay, that is it for today. Thank you. Homework. Let's talk about homework right now.